Hi, in this session, let us see how to apply superposition theorem to find the response through any one of the branch in a given DC network. So here, this is our DC network. Here, it consists of two sources, 12 volt source and 10 volt source. And we need to calculate current flowing through 4 ohms branch. So for that, instead of considering two sources at a time to calculate current through 4 ohms, I am applying superposition theorem to find the individual responses, and then later we can sum up the total two individual responses to calculate the total response. So for that, let current flowing through 4 ohms branch as I amperes when both sources are acting. If let I is the current flowing through 4 ohms branch when both sources are acting. So for that, first I'm doing is I'm going to deactivate 12 volt source. Now here two sources are there. Individual response means only one source we need to consider at a time. So 12 volt source is deactivating, means I'm removing 12 volt source. So 12 volt source. So it is voltage source because voltage source 0 means we need to short circuit it. So 12 volt source is short circuited. Now we need to calculate current flowing through 4 ohms branch due to this 10 volts. So for this, let I dash is the current through 4 ohms when 10 volts source is acting. So for that, before going to calculate I dash, I want to calculate total current. Then total current IT is total voltage by equivalent resistance. Then IT is equal to V by R equivalent. V is 10 volts divided by R equivalent is 4, 3. Both are in parallel. 3 and 4 are in parallel, and this combination is in series with 2 ohms. So 3, 4 in parallel and it is in series with 2. So finally the total current is 2.692 amperes because parallel combination of 3 and 4 is 3 into 4 by 3 plus 4. So 12 by 7, 10 by 3.714. So it is total current. Then current flowing through 4 ohms due to 10 volts. So my intention is to calculate I dash because we need to calculate current flowing through 4 ohms only. So I don't bother about 2 ohms or 3 ohms like that. So here I need to calculate I dash. I dash is IT is the total current which is divided along 3 ohms and 4 ohms. So I am applying current division rule for 3 ohms and 4 ohms. Then I dash is total current IT into other branch is 3 ohms by 3 plus 4. So finally I have I dash is 1.153 amps. This is the current flowing through 4 ohms branch when 10 volts source is acting. Similarly, in second case, I am going to deactivate 10 volts source. Means I am going to consider 12 volts source only by removing all the other sources. So we have, for example, here 12 and 10 volt sources are there. Like that, if 3 sources are there, we need to remove all the 2 sources by considering only one source at a time. So here, I am going to consider only 12 volts source alone. So again, I double dash is the current flowing through 4 ohms due to 12 volts. Then I need to calculate IT, total current. Similar to the previous case, V by R equivalent. V by R equivalent is 2 and 4 are in parallel. It is in series with 3 ohms. So 12 by 4.33 is 2.769 amperes. Then after calculating total current, we need to divide it through 4 and 2. So I need to calculate 4 ohms current. So I double dash. So I am applying current divider rule again. So total current into other branch by sum of total resistance. So total current into other branch is 2 ohms divided by sum of total resistance. Then I double dash is 0.923 amperes. So this is the current flowing through 4 ohms branch due to 12 volt source. So individually we have calculated what are the currents through 4 ohms. So these are the individual responses I1 and I double dash. Now in order to find out the total current through 4 ohms branch, we need to add these two responses. That is total response through R3 ohms branch, that is 4 ohms branch, is equal to sum of the individual responses. So finally I1 plus I1, I double dash, I dash and I double dashes are added together to find the total current as 2.076 amperes. So here in case 1, 12 volts source is short circuited, means 10 volts source acting alone. And in case 2, 12 volt source acting alone. So like this, if here in this case 2 sources are there, so that's why we are considering only one source by removing all the other sources. Like this, if a network consists of 3 sources, then we need to consider only one source at a time by removing all the remaining 2 sources. Like this, we need to consider 3 individual responses, and then we have to sum up those 3 individual responses to find out the total response. So like this, simply we can apply superposition theorem to any DC network. Instead of calculating the response through that branch by considering all the sources at a time, it becomes complex.